Hello guys, welcome to Makaut CSE and also welcome to our video on numerical methods in computer science and IT departments. Okay, so in this subject we have lots of numericals and lots of chapters. Okay, so this is the part 1 of the video. We will make two videos, like part 1 and part 2 for numerical method subject, and we will discuss each topic in clear concept and in detail, and with solve numerical questions. Okay, and how to approach the numerical methods problems and how to solve this type of question in exams. Okay, so in part 1 video, means today's video, we will discuss 4 topics. At first we will discuss the introduction, then we will discuss about the root finding algorithm. This is also known as we will discuss. Okay, when we will discuss, we will say. Okay, number 3, the calculus of finite difference. Okay, you can see here the subject code. Okay, PECIT 601D. Okay, so number 4 topic is interpolation. Okay, at first the introduction. Actually the numerical method, actually it is the approximation. Actually in previous engineering mathematics subject we already solved lots of integrals, differentiation, okay, and algebraic equations, linear simultaneous system of equations. But here in this subject we will do the same thing but in different ways, because we don't directly actually solve the numericals or like formula, use the formula and create our answer. But here we use some algorithms like root finding algorithms. Okay, some we will deal with approximation. The answers will be our approximations, like therefore like various type of decimal places we need to match for our answer. Okay, so we will deal with different types of algorithms. So in the introduction part we will say that we will deal with two types of equations. At first the algebraic equation. So we already know that algebraic equations looks like you can say f of x is like a polynomial. Okay, it is a polynomial. Example is like so this is a polynomial. Also you can say it is also a polynomial, but there is no involve of any other function. There is a general form. Okay, no extra other function is involved in these two equations. Okay, so these are the algebraic or polynomial equation, you can say. But other type of equation like you can say transcendental equation, we will deal with that. Equation. Okay, there actually we will our equation involves some extra functions like cos x, sin x, okay, tan x, logarithmic function, exponential function. So this type of equations we will handle, like x e to the power x equal cos x. This is not an algebraic equation, this is a transcendental equation, because this equation involves some extra other functions. Okay, that's why, like you can say x log x equal 1.2. so here the log x actually involved, so that's why this is not a polynomial, this is transcendental equations. Okay, so some important points, like we can say that for trigonometric function, like here x sin x, so sin x, here x, this x actually in which measurement, radian or degree? We will deal with radians, no degree. Okay, we will deal this x with radian format, not degree format. Okay, in numerical method subjects. So in calculator you can change your mode, okay, from degree to radian format, okay. So that's why this is important. So now this is time to discuss about the chapter 2, numerical solution of algebraic equations. So we have a given equations, and we have some in the question we have some methods to solve the equation and find the root in approximate way, not a direct way, in approximate way according to the methods, okay. So it depends on methods. So we need we need some basic concept to enter this chapter, okay. At first we need to learn about the iterative method. Iterative method means in a numerical method, when we apply some method, we deal with various iteration. In first iteration we can get some root, in the second iteration we can get some different root. So in this way we have n number of iterations and we get roots. So when we stop, we will discuss in examples, okay. So first, suppose a curve. When we actually calculate the root of a function like f of x, right, f of x equal to when 0, at which point, which value of x, f of x will 0, so that x will be our root. So a curve actually passing when cut at which point of x axis. So here x equal to alpha point, we get that f of x cut the x axis at x equal to alpha, okay. And we have two boundary like x equal to a and x equal to b range, okay. So at x equal to a, f of x value is positive because this is positive y axis, and x equal to b we have negative y axis, okay. So that's why here f of x value is positive, here f of x value is negative, simple. So this type of shape or we deal with, or we can find our root when a curve intersect x-axis, because if a curve don't touch x-axis, so how we can find our actually our solution, right? So for finding a solution or root of every curve, it is very important that this curve actually touch or pass through x-axis, which shape or which you can say, okay. So we will deal with, okay. So now, okay, so now we have some terminology like error. Error means in every iteration we get some roots value, okay. So we know actual root like alpha, but we get different type of roots, this which is approximate to alpha. So what is error? Actual minus predicted. So alpha minus xn means in which iteration, like for first iteration we have alpha minus x1, for second iteration alpha minus x2. In that way, for nth iteration error will be alpha minus xn, okay. So this is the condition for convergence. Convergence means we actually converge and we actually close to our root. In for our case, the p and q value, it is very important, the terminology. P is the order of convergence and q is the asymptotic e dot constant. So this is a convergency conditions, limit of n tends to infinite and epsilon n plus 1 by, it means that, so the convergency conditions, okay. So you need to remember that. So in this chapter we will deal with 3 methods. So in examination any of the methods the examiner can be asked, and also you need to minimum 2 methods you need to prepare from these 3 to solve the numerical type of questions, okay. Okay, so at first we will discuss with bisection method. So at first the bisection method. Bisection method deal with the bisections, means we have a curve, means a function f of x, and we have an interval ab, or simply you can check from 0, 1, 2, 3 in that way, okay. Means we put this value in our function and check the signs of our functions like positive or negatives, like means we actually need to find out 2 points a and b. In that case we need to multiply and we actually check that the signs is same or different. If different, then we can process 2 iterations, okay, iteration 1, 2, 3. If same sign, we actually check or we actually find out the next numbers. Means we need to find out that which 2 points the symbol is different. Okay, so for the first case, initial case, we have iteration 0 and we actually find out the a and b, and now we need to average these two, mean bisect. So we get the another point, and now we need to check if at this point the function value is positive or negative. Okay, we need to check this value is positive or negative. According to that, we will deal that we will close to our interval. Means at the first time our interval was a to b. See, at the first time our interval will a to b and our root lies in the middle, okay, like alpha. At the second time, if we divide the a plus b by 2, we will close to our root na. So that's why, so interval will be small. At the first time interval was long, but in second time the interval was small. So in that way, in each iteration we will close and we will small our iteration, or we will small our interval, we will close to our root alpha. So in that way the iteration will be processed. So we will discuss with one example. Okay. See first examples. We have an equation x to the power x plus 2x minus 2 equals 0. Okay, and we need to find out the root, correct, up to 2 decimal places. We will discuss it means what. Okay, at first we need to find out the roots by using bisection method. Okay, so at the first case we need to check that at the first case f of x equal x to the power x plus 2x minus 2. Okay, so we will put our value like f of 0, then f of 1. Okay, so f of 0 will how much? So we will start with here you can see that 0 to the power 0, this is undefined. Okay, so that's why we will start with 0.5. You can start with any value like 0.1, 0.2, 0.3. Okay, but here for a greater accuracy or minimal steps we can start with 0.5. So we will get our value like after putting this minus 0.293. Okay, and for f of 1 we will get 1. Okay, so now you can see that the function values is same sign or different sign. So root lies between these two, very simple. And you can also analyze from the graphs like function value at initial case negative and case positive. Okay, so negative and positive, so in the middle our root will lies. Okay, so we can say that our initial a equal 0.5 and b equal 1. A and b means the x points. Okay, and in the y direction we will find the function's value. Okay, so at iteration 0 we have the value of a 0.5 and value of b 1. So x1 will be 0.5 plus 1 by 2. So we will get 0.75. And for f of x1 means we will put our 0.75 value in the f function. So we will get our value 0.3059. You can use calculator for calculating this value. Okay, so now check the function's sign, like greater than 0. So we will modify which point. See, at the initial case our value will looks like this, like 0.5 and 1. So we can put like 0.5 and 1. It's like 0. Okay, so now the new point is 0.75. okay, 0.5 here, you can 0.75. so our interval was at the first time was this, and for the in this case we have our interval need to close. Okay, means we can now deal with this interval. At the first case we will deal with total interval, but in this iteration we will small our interval. Okay, so we will use the updated values of a and b. Okay, so in this case you can see the graphical analysis. Okay, at the first time our interval was a to b, so now we will get our new point 0.75. At 0.75 the function value is positive, means we don't need the v, we actually deal with x1, means a to x1, we don't need b. So we will close to our root, because our roots from distance from b, this is longer, from x1 this is closer, so we will update the b's value to x1. So now, so iteration 2, or you can say the iteration 1, because we will start 0, so 0 to 1. So now in the iteration 1 we have a1 and b1. So a1 will what? A1 will 0.5, but b1 will, now the new value of b means 0.75, and now we will check our x2, means 0.5, means the sum of two value by 2, 0.5 plus 0.75 by 2. Okay, so we will get our f of x2. So this will what? 0.625, and f of x2 means minus 0.0045. Now see that now the function value is less than 0. So now also check the intervals. Okay, and see the graphical analysis, so you will get the better understanding. So for the graphical analysis you can visualize in this way, that this was our a, and this is now our b value. Okay, 0.75 and a is 0.5. now see the x2 is 0.625, mean in which positions? Can you observe that? Like 0.5, so near in this way, like 0.625. In that case the function value is negative. Okay, so now we will close to our root. So which value will be updated, a or b? A. Okay, because we don't need the a, we will deal with 0.625. so now our interval will be, this is x2 to b, not a to b, x2 to b. Okay, so now our interval will x2 and b. In this case our value was a 0 and x1. Okay, so now iteration 2, so we can check that our values like a2, b2. Okay, so a2 will what? 0.625, and b2 will what? 0.75. Okay, so our x3 will be sum of 2 by 2, 0.625 plus 0.75 by 2, we will get 0.685. We will get the 0.687. Okay, now check the value f of x3. We will get the positive, like 0.1466. Okay, so in this way, we can check that the function value is greater than 0. So now observe the graphical analysis. Now our new points like A2, A2 and B2. Okay, so 0.625 and 0.75. Now check, the function value is positive, means in this portion, and our point is 0.687, so 0.6 is 0.75, so 0.687. so now we update our B2 value. Okay, update our B2 value. So now the interval will 0.625 to 0.687, not previous these two interval. Okay, so our interval will new, like x3 to, like our interval will A2 to x3. Okay, so in this way, like the third iteration, like fourth iteration, so in this way we will solve our questions. So we will actually close to our root. So in this way, the third iteration, we actually see, we actually this x1, x2, these are the roots. Okay, these are the roots. So this is already the answer, so we already gets, but we need the accuracy. Like in the questions we have 2 decimal places we need to match after decimal places, like in 0.75, but in second case 0.625, so there is no match. Okay, but in this case 0.687, so no match. 0.625 and 0.687 means after decimal places we need to match 2 decimal places. After decimal point we need to match the 2 decimal places in the simultaneous iterations, so there is no match. So we need to iterate for a long time. Okay, the third iteration is like this, and we have found that our function value is positive, so we need to update according to that, or you already understand that A3 and x4, and our value is 0.656, the root value. This is actually the x4. Okay, so now we will deal with the fourth iteration. So here, according to that, we actually solve our questions in 4th, 5th, 6th and 7th iteration, and according to that we need to change. Means in 4th iteration we actually solve and get that our function value is greater than 0. So here we need to check, like A and B, this here A4 and B4, and the value is 0.640. So see, A is 0.625 and B is 0.656, and our x5 value is 0.640 and also positive, so it's positive portions, so 0.640. Okay, this is less than, so though this is x5 0.640. Okay, so our interval will be 0.625 to x5. Okay, so in the next case we will modify our B value, so B value is modified. Okay, so from according to that we can solve our questions. But see, now the answers, like in every case you can see that there is no match, but see in number 6 and 7 iteration we see that 0.628 and 0.626. so now we will stop our iteration, because after decimal point 2 decimal places are matched, 6 to 6 to, so that's why we will stop our iterations. So our answer will be what? Now anybody can write that answer will be 0.626, but stop, please stop. See, we need to neglect this portion. Okay, because we just write 2 decimal places after decimal point. So there is a rule of round off, means if this value is greater than 5, because here this is 6, so we need to update this to plus 1. Okay, means 0.63, 2 plus 1 3. Okay, for removing this element. Okay, so this is our answer, like 0.63. Okay. So now this is time to discuss about the regular falsy method. So we solve one example in bisection method, and now regular falsy method. Regular falsy method deals with a straight line method, we can say that, or false position method. Okay, this is a traditional or old method. In regular falsy method we have a function and 2 points x0, x1, and according to that we will get x2. we will get x2, okay, by using some functionalities. In which format? Like we have x0 and x1, and according to that f of x0 and f of x1. So 2 points and a straight line. So this straight line pass through x-axis or cut x-axis at point x2. We can assume that means in this way, x0 and x1, and also in this portion is we can imagine in this way, x0 x1, and alpha means roots, and our straight line pass through this way and x2. Okay, so this x2 means at point x2 y equals 0 in this point, and this point is close to alpha. Okay, so for this we construct our straight line equation. We know this is the straight line equations, and in this equation we can put x equal to x2 and y equals 0, because at x equal x2 y equals 0, we know that at x equal x2 y equals 0. So we will get these equations. This is the general equations. Okay, so this is the general equation. This is a general equation for regular falsy method. Okay, so now we will solve one example. Here n will start from 1 because we have x0 x1, so next value will be x2. Okay, so we will already solve one question. Like this is the equation you have given, and interval will be given like 2 to 3, and 4 decimal places we need to find out our roots. Means after decimal point we need to match the 4 decimal places, and by using regular falsy method. So regular falsy method, what say that we have a function and we already given x0 x1 like 2 3, or in some cases the points will not given. So at that point you need to check like 0 1 2 and check which points the function sign is different. This is the same in bisection, or you can say regular falsy. This is the same process. Like we need to check the signs. So according to that we plot our graphs, and you can check that this is our alpha, and x equal to 2 the function value is negative, at x equal to 3 function value is positive. So root will lie in between this middle portion. Okay, so now this is our formulas. So we will get our x2 value. So according to that we will find out the first iteration. So according to that we construct this table like x0 like x1 like first iteration, second, third, fourth, and according to that in the number 6 iteration we suddenly see that our values, like after decimal places, after decimal point 4 decimal places is matched. So now we will stop. This is a simultaneous, means not like 4 and 6 is matched. No, we need to match simultaneous. Mean if 4, then it will match to 3 or it will match to 5, not 6. Means if I find out in 5, now I need to match it with or 4 or 6. Here the match is 5 to 6, because after decimal point 7473 7473. So that's why this is simultaneous iteration and this is match. So now our answer will be 2.747345, means this. But now we need to round off. Now we need to round off, means after decimal point we need 4 decimal places. So that's why we will neglect this. But before neglection we need to verify that this point, means after 4 decimal point the fifth position is greater than 5 or less than 5. It is less than 5, so no need to any change, just delete it or remove it. So now our value will be 2.7473. So this is the correct answer for these questions. Okay, so according to that you need to change, in every time you need to change these values. Means in first iteration it was 2,3. So now we need to check the values. If it is greater than 0, so according to that you need to change the xn minus 1 and xn. Okay, so you can do this by same process like bisection method. So okay, so now this is Newton-Raphson method. So Newton-Raphson method, this is also known as tangent method. Why? Because we have a curve and we actually plot at x equal to x0 point, we actually plot a tangent in the curve at x equal to 0 point. So at x equal to 0 we have some function value, right? This actually lie in the tangent. So we already know the tangent equations at x equal to 0 at x0 point. This is the tangent equations. So now already you can see that this tangent passed through the x-axis or cut x-axis at point x1. So now and also the y value at this point of time is 0. So this is y axis and this is x axis. So this y is 0 and x equal to x1. So x equal x1 and y equal 0 we will put here. So we will get a equations. Okay, so this equation will be x1 equal x0 minus f of x0 minus f dash x0. So now according to that we will get our formula like this, like x of n plus 1 equal xn minus f of xn by f dash xn. Okay, so this is the our Newton-Raphson formula. So according to that we will solve our questions. Okay, so here we already solve our one examples, like we have equations and 4 decimal places we need to find out our roots, and Newton-Raphson method we will use. Okay, so now, so at first it is the primary through ready-made ready-made the functions and also the xn plus 1 equal xn. From this formula we will actually create these values. Okay, so now we need to find out, we have x0, but where x0? So we need to calculate the x0, means we need to find out our root lies between in which interval or which case. Okay, so we need to check like f of 0, f of 1, okay, f of 2. So f of 0 will means x equal to 0 we will put in this function. Okay, so we will get 8, we will get 2, or we will get minus 4. So here the function value symbol is changed. So you can imagine this function as, for x equal to 1 the function value is positive, for x equal to 2 the function value is negative. So x equal to 1 and x equal 2. So this is 2 and this is minus 4, we can assume. So the roots lies between 1 and 2. So you can actually assign x0 to 1 or x0 to 2. This is your choice, anything you can do it. Okay, and according to that you can solve these questions in the given formula. So first we actually assume the x0 equal 1. You can assume x0 equal to 2. Okay, okay. So x1 will be what? We actually, according to that we will put our value and we will get our values like 1 point x2 will be means in every case from x0 it actually generates x1, it actually generates the x2. Okay, in that way. Okay, so x3 will be six zero 7. So now 4 decimal places mean here 1 2 3 4. So we will stop over because in simultaneous iteration we will match our 4 decimal places. So 1.2260 now. So you need to check after this place we have here 7, right? So now we need to neglect it, but before that we need to round off, means 7 is greater than 5, so that's why you need to add plus 1 in this position. So 0 plus 1 1. So now this will, after round off, 1.2261. okay, so this will our actual answer. So this is how we can solve these questions, this type of question. Okay, so that is the end for the second chapter. Okay, but something is important, some numericals like theory questions like advantages of methods, each methods. and also the convergence, order of convergence. You need to deal with this type of questions, okay. And also some Newton-Raphson method applications can be asked in exam, like finding the roots for Newton-Raphson methods, okay. So this is the application of Newton-Raphson methods, like we can find out any type of root, like the mth root of a real number r. So we can say that we need to find out these types, okay. Mth root, like that, okay, here the root will be what, 2, means the second root of the real number 4. In that way the mth root of the real number r, okay. So how we can find out that, means we need the value, okay. So actually how we can get, by using the numerical method. See, we can assign x equal, because we need to find out the value of x in that way. So how we construct equations, so in both sides we actually power to m, means x to the power m equal, we can write this as 1 by m, and also because in both to the power m, so this, okay. So now this mm will be cancelled and we can say that it will be r, okay. So x to the power m minus r equals 0. So this actually are equations, some algebraic equations. Now we can solve this by using numerical methods, means f of x equal this, and f dash x will be what, m x to the power m minus 1 minus r, okay. So now by Newton-Raphson method we have x to the power n plus 1 equal x to the power n minus f of xn by f dash xn. So you can put this and you can get your answer, okay. So now you can put this value, like xn minus f of xn is x to the power m minus r, by f dash xn is m into x to the power m minus 1 by r. So according to that you can get your answer. This general form will be m minus 1 x to the power n m plus r by x to the power n m minus 1, okay. So here n will be what, n will start from actually 0, 1, 2, okay, according to that. So you can solve in your home. So these questions, like find out the cube root of 10, okay. Okay, so you can find out the cube root of 17. So okay, so it is a practice, okay. Okay, so that is the end for this chapter. Now we will move to our number third chapter, okay. So we will discuss. Okay, so now the chapter 3, the calculus of finite differences, okay. So this is very easy topic, and this is actually the basic portions for the interpolation chapters, okay. So this is the prerequisites for interpolation chapters, okay. So you can see that the some operators, okay, like we have some functions and we have some point like x0, x1, x2, x3, okay, in that way up to xn, and according to that we have y0, y1, y2, y3, okay, and up to yn, okay. So this pointer we can say that equidistance, means same distance, 1, 2, 3, so that's like that. So h will be the length of the interval, okay, length of interval, means x1, okay, means x1 to x2. So this is the interval, according to that. Okay, so xn minus 1 to xn. So here we consider this, we have equidistance. Finite difference, actually we have equidistance. Okay, so the symbolic representation, we can say that y0 you can also write is as f of x0, yn you can also write it as f of xn. Okay, same things. So this is a symbolic representations. Okay, okay. So now we have some operators like shifting operator, but before that we can see that some interesting topic like x0, x1, x2. So in the x-axis we have 3 points. What is the relationship between them? So x1 will be x0 plus h, because this is interval is h length, na? So x1 equal to x0 plus h, because you consider this is 0. So 0 to x0 and x0 to h, we can get x1. So x1 equal to x0 plus h. According to that, x2 equal to what? x1 plus h. Okay, so this is the length. Okay, and this is the relationship between each x variables. Okay, so now shifting operator means, so the first operator will be shifting operator. Shifting operator. The symbolic representation is E. So it actually operates on a function f of x. Okay, so E of f of x will be what? F of x plus h. So in general, x plus nh. Okay, according to that. Okay, so in the same way, can you guess the value of this? This will be f of x just, so f of x minus h. Okay, so it is very important, e to the power what? E to the power what? This n will actually multiply with h. So here n is minus 1, so minus 1 will multiply with h. This is minus h. So in a function we just replace x with x minus h. Okay, okay. So now the important two operators, that's we deals with the interpolations like forward difference operator. Okay, so in forward difference operator, the symbolic representation is this. Okay, so it defines as del of f of x equal f of x plus h minus f of x. This means what? You can, the graphical representation like this is x and this is x plus h, and the function is like this. So this is f of x and this is f of x plus h. So the difference between these two values, forward difference means the forward direction difference means f of x plus h minus f of x. Okay, and similarly the backward difference operator. Like it defines as the symbolic representation is lambda. Okay, this will be f of x minus f of x minus h. Okay, Okay, so can you imagine that del of y0 means what? It means what? Del of, recently we can see that y0 means f of x0, so del of f of x0, it means what? It means f of x0 plus h minus f of x0, simple. So f of x0 plus h means f of x1 minus f of x0. F of x1 is what? Y of 1 minus y of 0. So we get that del of y0 equal y1 minus y0. This will actually working in Newton forward and backward difference formula. Okay, so please remember these concepts. It is very important for that purpose. Okay, so now we have two operators, central difference and averaging operator. For central difference, the symbol is this, and for averaging operator the symbol is mu. Okay, so it defines as f of x plus h by 2 difference operator. Okay, so f of x minus h by 2, but in averaging operator it is defined as half of f of x plus h by 2 plus f of x minus h by 2. So two concepts important, very central difference and averaging operator. Okay, so now this is the fundamental theorem from differential calculus. Means we if we have a polynomial and if we differentiate, if we actually iterative method, if we n times calculate the difference operator, then we will get that a constant. Okay, so a0 n factorial h to the power n, here h is the length, h means the length, okay, of interval, means x0 to x1 h is the length, x1 to x2 h is the length. Okay, for n time this is constant, but in after that n plus 1 time this actually varies, so that's why the nth order difference of a polynomial of degree n is constant. This is constant, and its n plus 1th order difference is varies, means it actually is 0. Okay, so that's it for that. Some important formulas you can prove, or this is the important properties you can say, like okay, see, these are the some properties for finite difference calculus. Okay, please remember these equations, because this is very important for solving the numerical questions, and short questions can be asked from these portions. Okay, and it is related, means if you can prove this, then you can prove this. Okay, so this is the interrelated. Okay, so this is, you can say, central difference operator, backward it is averaging operator. Okay, so where d means the differential operator, d by dx. Okay, okay, so in examination it can be asked that the relationship between the central difference and averaging operator, so you can write this way. Okay, So this formula is also important. Okay, so now we will start our new topic like divided dependence. Divided dependence is important for Newton divided dependence method understanding related. Okay, so the symbolic representation, this like that, you have y equal f of x. Okay, and the interval to be okay. So now f of 0 comma x1 we will detailedly understand in the Newton divided dependence formula, but before that we need to a basic concept. So that's why we need to learn these things. So how we will represent? This is a symbolic representation of divided difference operator. Okay, so the symbol for divided difference is this, but we will use this representation. Okay, so we have some points and like x0, x1, x2, x3. Okay, and according to that y0, y1, y2, y3. Okay, so now divided difference will be for x0 and x1, it will be but how you can remember this in a magic way, like if the length you can see that this is 2, right? So here the length will be 1 and 1, means the 1 length. If there is a 3 length, then there will be a 2 lengths in that way, similar way. Okay, so for 3 lengths what you can do, see for 3 length f of x0, x1 and x2, how you can write? At first 2 length means there is a 3 lengths, for 2 length means x0 x1, then x1 x2, x0 x1, then x1 x2. It means at first and then, okay, in this way. So x0 x1, x1 x2. Okay, by x0 minus x2. See, the difference is terminals like x0 to x2, x0 to x1, but in the middle case you need to describe in this way. Okay, so see f of x0 x1, that is similar to f of x1 x0. Okay, in this order. Okay, so this is the basics for divided difference. So now we will go to our interpolation formula. See, some questions can be asked from these chapters like this, like del square 5x plus 2 by x square plus 5x plus 6. Okay, this is 12. Okay, so how you can solve these questions? Okay, so you can solve these questions by some similar way. Okay, see, at first you can divide this by now, according to that you can find a and b. Okay, this means like arrangement, how you can arrange this. Okay, so this constant will be removed and it actually in the outer portion it will be so 1 by 6, and then del you can see 2 dels. Okay, so we can divide this by means we have two portions, like first this and second this. So 2 by x plus 2 plus of del 3 by x plus 3. Okay, so now you can according to this you can solve like the definitions from del, you can solve these questions. Okay, so according to that. Okay, and some important you can say the numericals like del of 2 to the power x by x plus 1's factorials. Okay, you can solve in your home. Okay, you can solve in your home. So this is the basic concepts from this chapter. Okay, see the interpolations, it is actually the chapter number you can say 4 from our point of view. Okay, so interpolation means you have a given some x value and y value, and according to that you in questions you have some x value and you need to find out the y value according to that. Okay, so interpolation means the finding the unknown value of y for the given value x, but is x is between these points. Okay, but it is not directly given, you need to find out the value. Means if your table is like 1 2 3 for x value and y value is like 2.5 3.3 and 4.1, so now you need to find out the value of y for x equal to 2.1, but 2.2 is there, but 2 point is not there, but 2.1 is lies between 2 and 3 na. So this is called interpolation. You need to find out the value of y according to the value of x, which is lies between these points. Okay, so we have some 4 methods like equal interval methods and unequal interval methods. If from equal interval we have 2 methods like Newton forward and Newton backward, and from unequal interval we have Lagrange method and Newton's divided difference methods. So we will solve one questions from each portions. Okay, so according to that you can solve any questions, any type of in easy concepts. Okay, so please watch this video in concentrate mind. Okay, see, so now it is time to discuss about the Newton forward difference formula. So this is our formula, means for the given x, okay, x equals something in the questions, and we need to find out the y value. So at first we need to find out this polynomial or construct this polynomial from according to the table. See here, at first we have a given table, and according to that we need to construct a forward difference table. For backward we need to construct backward difference table. So we will solve this by using some questions like if you have a questions like this, like x equals 0 1 2 3, and according to that f of x is 1 2 1 10. Okay, so now you need to find out the value of f of 4. Okay, it means f of 4 means x equal to 4, at x equal to 4 f of 4 is what? So this is the questions, and use the Newton forward difference NFD. So how you can do that? At first you need to construct the forward difference table, means x value, y value, means this from the formula you can see that you need these values. P value automatically calculated. Okay, so see the values. X means 0 1 2 3. Okay, so this is x0 will be, and y0 will be what? 1 2 1 10 from this table. Okay, so now del y means what? At first how we can imagine this like this, in this way. This type of differences means first 1 and 2 means 2 for this you need like 2 minus 1 1, 1 minus 2 minus 1, and 10 minus 1 minus 9. Okay, so in this way This is minus 1, minus 2. Minus 9, minus plus 1. Means minus 9 plus 1 is what? Minus. So this is 10. So from this difference we have 10 minus or minus 2 means plus 2. So 12. Okay. So this is the values. Okay. You can see. So now we put means p value. P value means x minus x0 by h. Here h means what? H means the gaps between x0, 1, 2. So gap is what? 1. So h equal 1. And x is x, and x0 means the first value of x 0. So it is very easy. So x, so p equal x. So we will construct our polynomial. Okay, see. The polynomial f of x will be what? Same way. y0 plus p del y0 plus p minus 1 by 2 factorial del 2 y0 plus p of p minus 1 by 3 factorial p minus 2 to del 3 y0, and according to that. For here we will stop our calculation in del 3, so that's why we don't need to go further. Okay, so now we will put up formula. y0 means what? y0 is first value of y. First value of y is 1. Okay, so first value of y 1. P value is what? P value is x. Del y0 1 dot 1 plus, and according to that x minus 1 by 2 to minus 2 plus of x into x minus 1 into x minus 2 by 3 factorial means 6 into 12. Okay, see, after calculation you will see that 2x cube minus 7x square plus 6x plus 1. This will be our interpolating polynomial. This is known as interpolating polynomial. Okay, so now you can directly put your value, and you will see that f of 4 is 41, and if this is the actual value. Okay, so by this way you can use the forward difference, Newton forward difference. Okay, so this is the interpolating polynomials. Okay, so now we can see the Newton backward difference formula. Here the calculation will be in backward format. The backward difference operator we already studied in the previous chapter in the finite difference calculus. Okay, so now we have a x and y. Okay, so see the numerical questions. Okay, we need to find out the value of f of 2.28. so we have the backward difference table. See the calculations from backwards difference means from down to tops. Okay, so according to that we can calculate like this way. So at this point of time the only one value is this, so we need to stop at this point of time, and the p value, like p equal, for the formula we need the p value. Okay, so p equal, we can calculate this. Okay, see the f of 2.8. so you need to construct this polynomial and just put x equal to 2.28. according to that you can find out this value. Okay, and please check the answers. Okay, so this is the example for Newton forward difference formula. Okay, so now we need to learn about the interpolation for unequal interval. So we use two methods. At first the Lagrange interpolation polynomial. Okay, we have some given points, data points like x0, x1, x2, x3 and x4, y0, y1, y2, y3 and y4. Okay. So Lagrange interpolation polynomial will be look like that. Okay. So see the values. Okay. So x1, x2, x3, x4, x1, x2, x3, x4 and multiplication of y0. So according to that, in the next case, plus of in this way, in similar format, you can do that. Okay. So according to that, so for x0 this is calculated, for x1 this will be calculated, x1, x1, x1. So x minus, x minus, x minus and x minus. So x0, x2, x3, x4. According to that, x0, x2, x3, x4. So in this way you can easily construct these equations. Okay, y0 and then y1 multiplication of, so in this way. So here we will stop what, when we will reach y4. Okay, so y0, y1 like y2, y3 and y4. So in the question, if you have a data sets and you need to find out the Lagrange interpolation polynomial from the given table. Okay, so we can solve a question according to this. So now we have a questions. Okay, so f of 1, f of 2, f of 3, f of 4, f of 7. Okay, so value will be 2, 4. This actually given in the question, and you can see the first 1, 2, 3, 4 difference is 1, but in this case 4 to 3 this is 3. So that's why we will apply the Lagrange polynomial, because here unequal interval is there. So we will construct, the question is that the construct Lagrange polynomial. Okay, Lagrange polynomial. Okay, so f of x will be at first for x0 we need to find out, y0 will be what, 2, but here actually we will understand by table format, take x and y like 1, 2, 3, 4, 7 and 2, 4, 8, 16 and 128. So okay, so see, so 3, 4, 7, 3, 4, 7. So okay, 1, 1. Okay, 3, 4, 7. So this is in similar way, plus x minus 1, x minus 3. So this is for x equal to 0s, means x0. y0 here will be what, y0 means 2, so y0 will be 2, multiplication of 2. So minus 4, x minus 7 by 2 minus 1, 2 minus 3, 2 minus 4, 2 minus 7 into what? Into 4. Okay. Okay. So according to this way, last is into 128. So we will construct and see our polynomial. This is a big polynomial, so here that's why we actually not write our polynomial. So you can check your answer from books also. Okay. So this is the Lagrange polynomials. So now we will see the Newton's divided difference formula. Okay. So now in Newton divided difference, this is the formula. Okay. So now this is the divided difference table. So it is very difficult to construct because please see the situations. Okay. So at first, so we need to put we need to calculate these values. Okay. At first, like in the initial phase, this value, how we calculate this? See, like for this minus 21, the formula was what? Like f of x comma x1, or you can say x0 equal to f of x minus f of x0, okay, by x minus x0. So now according to this, this is the no interval is there, so we can construct like at the first scenario is minus 21 minus 15 by minus 1 minus of 1. Okay, so 18 is the value, so 18. So according to this, this value will be okay. So in this case we need to have 1 interval, means okay. So from this you can see the gaps. Gaps is always like you can say in the second case, because the length is 3, so we will find our values in 1 gaps, means in this case the first value will be comes from this, means 18 minus of minus 3, but x value will differ, means minus 1 to 2, means this one is not included, means we will remove 1 intervals. Okay, so minus 1 and 2, minus 1 and 2, the formula symbol is minus. Okay, so 21 by minus 3, so minus 7. Okay, so according to this we can put and minus 3. So in this case here we actually remove the 1 interval, so here 2 removal, 2 intervals, means minus 1 to 3. So the values will be minus 7 and minus 3, minus 7 and minus 3, symbol is minus. Okay, so okay, see, so here the minus 4 by minus 4, so will 1, so the value will be 1. So now put these values in this formula, you will get the actual polynomial. Okay, so answer will be x cube minus 9 x square plus 17x plus 6. So that's it for today's video. Okay, so we complete our numerical methods topic. Okay, so we cover lots of methods ratio. Okay, so now you can see we covered each topics like interpolation, calculus of finite differences, root finding algorithm, and introductions. So it is part 1 video. Remember that for part 2 will comes with another interesting topics. Okay, so thanks for watching. guys. So that's it.